International Women's Day celebrates the fact that women around the world are united and has been fighting to create an equal platform for all irrespective of gender discrimination. International Women's Day started during the Great Unrest of 1908 in the city of New York. In the early to mid 20th century, they were getting demeaned for their policies, and this actually enforced them to question their ignoring governments. This act eventually led to a widespread protest of various women groups to fight against their negligence and raise their voices. After which, to celebrate the success, 8 March was marked as International Women's Day. Today, we see many women following the same path. Provided equal chance, women are capable of achieving anything in this world. Every year, we celebrate Women's Day with different themes and issues to focus on. This year, Women's Day Special is all about Choose to Challenge, and we really support this initiative. Recently in RCB, we celebrated the journey and contribution of two eminent Indian women scientists. Let's have a look.
There are only a few Indian women scientists that have been duly recognized during their lifetime for their brilliance. Today, we are going to talk about Dr. Asima Chatterjee, an organic chemist and the first woman to earn a doctorate degree from an Indian university. Asima Chatterjee was born on 23rd of September 1917 in a middle-class family in present-day Kolkata, India. Her father, Indranarayan Mukherjee, was a medical doctor who had a great interest in botany, and Asima shared his passion for the same. She had one sister, and they both were encouraged to get education, which was a rarity for women at that time. In an era when the woman did not commonly pursue higher education, Asima chose to study chemistry. She graduated with honours from Scottish Church College, University of Calcutta in 1936 and received the Basanti Das Gold Medal for the same. Asima continued to break the mold and went on to pursue a master's degree in organic chemistry from the University of Calcutta and obtained the degree in 1938. She did not stop at this and went on to do her DSc at the University of Calcutta. She was the first woman to receive a doctorate at an Indian university in 1944. As a doctoral student, she worked on the chemistry of plant products and synthetic organic chemistry with the renowned chemist Prafulla Chandra Ray, also known as the father of chemical science in India, and she also worked with Satyendranath Bose, the famous physicist. She also worked with Laszlo Zeigmeister at the University of Wisconsin and Caltech Pasadena for her postdoctoral research on biologically active alkaloids. She later joined Lady Brabourne College, Calcutta as the founder head of the Department of Chemistry in 1940. She was also appointed as the honorary lecturer in chemistry by Calcutta University in 1944. Her passion to work on naturally occurring glycosides took her to USA, where she joined the University of Wisconsin. She was also awarded with the Watermill Fellowship for recognition of her work on biologically active indole alkaloids with Professor P. Kehrer, University of Zurich during 1949-50, which became her lifelong interest. After her return to India in 1950, she started research on alkaloids and coumarins with renewed vigor. In 1945, she married Professor Bharatananda Chatterjee, a physical chemist. Professor Bharatananda Chatterjee himself went on to become the head of the Department of Chemistry, Geology and Metallurgy and Vice Principal of the Bengal Engineering College, Howrah. Professor Bharatananda Chatterjee had a profound influence on his wife. Without his constant inspiration, encouragement and cooperation, it would have been impossible for Asima to dedicate herself to the cause of science. Members of Dr. Asima's laboratory considered themselves as one large family, and to this her husband had much contribution. Asima's legacy lived on in her daughter Julie, who had the same passion for research and organic chemistry, who would later grow up to become the head of the Department of Chemistry at University of Calcutta. Professor Chatterjee's life was a unique example of harmony and commitment between professional and home life. She had always been a devoted wife, mother, daughter, elder sister, mother-in-law, and a grandmother. Over her career, which spanned an impressive 60 years, she not only broke the glass ceilings and laid the groundwork for female scientists in India, she also developed drugs that impacted the lives of millions of people around the world. She once said that she wished to work as long as she lived, and that's what she did. Asima passed away on November 22, 2006, at the age of 89.
In India, time for science was difficult and the funding was scarce. Dr. Chatterjee had to spend her personal money on sending samples for analysis abroad. There was not enough funding to pay for her students' salaries and she struggled to get the necessary chemicals and reagents. Moreover, there were no NMR or other advanced spectroscopy techniques to analyze the compounds. Dr. Asima and her students relied on old instruments for purifying the very small amounts of compounds from the plants. However, Dr. Asima and her students were an extremely dedicated lot and worked hard to achieve some wonderful results. Dr. Asima made significant contributions in the field of medicinal chemistry with special reference to alkaloids, coumarins, and terpenoids. She published around 400 papers in national and international journals and more than a score of review articles in repeated serial volumes. Her publications have been extensively cited and much of her work has been included in several textbooks. She worked for almost 40 years on the chemistry of alkaloid compounds and natural compounds. Her research resulted in many anti-epileptic, anticonvulsive and chemotherapy drugs. Her work led to the development of a commercial anti-epileptic drug that is still in use called Ayush 56. She was instrumental for establishing the National Research Institute of Ayurveda for Drug Development in Kolkata. Among her contributions, a few notable ones are she initiated chemical investigation of alkaloids in Rauwolfia canescens. She investigated the chemistry of almost all principal types of indole alkaloids. She contributed with regard to elucidation of structure and stereochemistry of agmalicin and sarpagine. She carried out synthetic studies on a number of complex indole alkaloids, quinolines, and isoquinoline alkaloids. She developed simplified and normal procedure for preparation of required beta-phenylethanol amines in connection with alkaloid synthesis. She studied the action of various Lewis acids on phenylated coumarins and devised simple synthetic routes to a number of complex systems. She also investigated the mechanism of acid-catalyzed hydramine fission of beta-phenylethanol amines and also introduced the use of periodic acid as a reagent for the detection and location of both terminal and exocyclic double bonds in organic compounds. Professor Chatterjee was elected a Fellow of the National Institute of Sciences of India, which is now known as Indian National Science Academy, in 1960. From 1962 to 1982, she was the Khaira Professor of Chemistry, one of the most prestigious and coveted chairs of the University of Calcutta. She is the first lady scientist to be elected as the Journal President of the Indian Science Congress in 1975. Those who attended the 62nd session of the Congress held in New Delhi in January 1975 will remember Mrs. Chatterjee's eloquent and powerful presidential address, Science and Technology in India, Present and Future, reflecting her vision and foresight. In 1975, she was awarded the title Padma Bhushan, the third highest civilian award by the Government of India. The same year, she was recognized as International Women's Year. She was honored by the Bengal Chamber of Commerce as the Women of the Year for her scientific contributions. She was nominated by the President of India as a member of the Rajya Sabha from February 1982 to May 1990. She received the Shanti Swarup Bhatnagar Award in 1961 for her valuable contributions in the field of chemistry of natural products and became the first female recipient to receive this award. Professor Chatterjee is the recipient of multiple awards and honors for her significant contributions, which include Sir P.C. Ray and Professor P.K. Bose lectureships of the Indian Chemical Society, Sir C.V. Raman Award of the Hari Om Ashram Trust by the University Grand Commission, the Indira Gandhi Priyadarshini Award, the All India Unit Conference, the Silver Jubilee Award of the Central Council for Research in Ayurveda and Siddha, the Eminent Teacher Award by Calcutta University, and the Ratindra Award of the Visva Bharati University.
Let us choose for ourselves our path in life and let us try to strew that path with flowers. Dr. Janaki Amal truly personified these words through her life. She was one of the first women scientists from India who made significant contributions in the fields of cytogenetics and phytogeography and even has a flower named after her. She was a pioneer who has come to inspire generations of female scientists in India. Through her mettle, she fought against heavy odds in an area where women had seldom presence. Her life is indeed a glorious chapter of women liberation and empowerment in post-colonial India. Janaki Amal was born in Tellicherry in Kerala on November 4, 1897. She was the 10th child of Srimati Devki and Sri E.K. Krishnan, who was a sub-judge of the Madras Presidency. She was born in an era when most Indian girls were not even sent to school and women were discouraged from pursuing their professional interests. However, she was lucky enough to be born in a family which was open-minded and wanted her to engage in intellectual pursuits. She developed an affinity towards natural sciences, and her desire for learning based on keen observation was passed on to her by her father, who himself was very close to nature and even wrote 2 books on the birds of North Malabar region. Janaki completed her schooling from Sacred Heart Convent School in Tellicherry and developed an early interest in botany. Then she moved on to Madras, where she obtained a bachelor's degree from Queen Mary's College, followed by an honours degree in botany from the Presidency College in 1921. While at the Presidency, she developed a keen interest in cytogenetics as well. After her graduation, she taught for some time at the Women's Christian College, Madras, before winning a scholarship to the University of Michigan at Ann Arbor. And in 1924, this Malayali lady, dressed in a sari, set sail across the seas to a land that she had never seen before. Born in colonial and patriarchal India, Janaki had to face many hurdles of her own. At a time when the literacy rate among women in India was less than 1%, she chose a life of scholarship over matrimony and went to the University of Michigan, where she completed her master's in 1925, followed by a PhD in 1931, again as the first Oriental Barber Research Fellow, thus becoming the first female doctorate in botany from an American university. Her thesis was titled Chromosome Studies in Nicandra physaloides. Her research career began when she joined the Sugarcane Breeding Institute, Coimbatore, as a geneticist in 1934. The institute was created with the aim of improving the Indian sugarcane plant. At the institute, she worked on sugarcane biology along with T.S. Venkatraman, who had successfully increased the production of sugarcane in the country over the past few years. Ammal's expertise in the field of cytogenetics and her research in polyploidy helped to understand the nature of polyploidy in sugarcane, and she was very instrumental in creating a firm scientific basis for crossing and hybrids and helped in choosing plant varieties for crossbreeding. She worked at the institute till 1939. At that time, the sweetest sugarcane in the world was the Saccharum officinarum variety from Papua New Guinea, and India used to import it from Southeast Asia. By manipulating polyploid cells through cross-breeding of hybrids in the laboratory, Janki was able to create a high-yielding strain of the sugarcane that would thrive in Indian conditions. She did some really epochal work on various intergeneric hybrids such as Saccharum zea, Saccharum erianthus, Saccharum imperata, Saccharum sorghum. Her pioneering work was on the cytogenetics of Saccharum officinarum and interspecific and intergeneric hybrids involving sugarcane and both closely related grass genera and also very distinctly related ones such as bambusa. Her research also got published in one of the most renowned journals, Nature. When the pollen of Spontaneum fertilized the eggs of Officinarum, the products retained the full chromosome complement of Officinarum, thus generating a hybrid sugarcane plant which was as sweet as Officinarum and had robust stalks as in Spontaneum. Success was thus achieved in producing sweeter varieties of Indian sugarcane, and these Coimbatore breeds were so successful that in the first year itself, they increased sugarcane production in Punjab by 50% and were even exported to places like Cuba. Dr. Janki's research also helped analyze the geographical distribution of sugarcane across India and also to establish that the Saccharum spontaneum variety of sugarcane had originated in India. C.V. Raman saw the spark in her and made her a foundation fellow of the Indian Academy of Sciences, founded by him in the year 1935. She thus became the first woman scientist elected to any of the science academies in India. However, despite being such an accomplished researcher, she had to face a lot of caste and gender discrimination, which compelled her to leave India and go to London to work at the John Innes Horticultural Institute. She was in London at the time of the Second World War. While describing her experience to her friends, she mentions about how she used to dive under her bed during the night bombings and then continue with her research work the next day, brushing the broken pieces of glass off the shells. Dr. Janki joined the John Innes Horticultural Institute as an assistant cytologist, where she worked with the great biologist of the time, C.D. Darlington. The eminent Englishman was impressed enough with his young colleague to ask her to collaborate with him in writing the Chromosome Atlas of Cultivated Plants, a landmark work published in 1945 which decisively reshaped the field. At John Innes, she studied a wide variety of garden plants. Her research on chromosome ploidy and number shed light on the evolution of various species. And it's very important to remember that these works were being carried on at a time when Britain was at war, and it was a very challenging time for science. Dr. Janki worked on several pioneer aspects of cytogenetics with C.D. Darlington, including adaptive isochromosomes of Nicandra, chromosome diminution, origin and behavior of chiasmata in polyploid tulipa, and published these in high-impact journal Nature. The magnolia flowers are an essential part of the charm of Battleston Hill in London's Wisley neighbourhood. However, what many people don't know is the fact that these blooms have a touch of Kerala to them. During the war years, that Dr. Janaki Amal had planted these magnolia flowers while she was working at the Royal Horticulture Society. She returned to her country in 1951 upon being invited by the then Prime Minister of India, Pandit Jawaharlal Nehru, who appointed her to reorganize the Botanical Survey of India. From then on, she was always in Government of India employment, heading the Central Botanical Laboratory, Allahabad, and being officer on special duty at Regional Research Laboratory at Jammu. She continued her work on polyploidy and evolution of plants and made immense contributions in the study of Himalayan and Northeast region flora. Dr. Janki majorly worked on phytogeographic diversification of species, including cytosystematic survey of bambuaceae to map chromosome number and distribution of cylinder bamboos across the globe, and also on chromosome number, species-genus relationship across different plant Lonicera species, Viburnum genus, and their distribution. Besides working on medicinal and other plants, she also worked on the genera Solanum, Datura, Mentha, and Dioscorea. Also, according to her, the confluence of Chinese and Malayan elements in the flora of northeast India led to natural hybridization between these and the native flora in this region, thus contributing further to plant diversification. After her retirement, she worked for a short period at the Atomic Research Station at Trombay and also served as an emeritus scientist at the Center for Advanced Study in Botany at the University of Madras. She continued to publish the original findings of her research, focusing special attention on medicinal plants and ethnobotany. In the Madras University Field Laboratory, where she lived and worked, she developed a garden of medicinal plants. During her last years, her main interest had been the rearing of a large family of cats and kittens. Her training as a geneticist led her to track down and discover subtle differentiations in the characteristics of the kittens under her care. She continued her research in medicinal plants and ethnobotany in her laboratory at Madura Royal and kept on publishing her work until her demise on February 7, 1984. Her obituary stated she was devoted to her studies and research until the end of her life. For her exemplary contribution to science in India, Dr. Janki Amal was awarded the Padma Shri in 1977. From a young age, she was endowed with the courage to make choices and the versatility to change course and adapt where and when required. With her passion for plants, she defined for herself her goals and purpose and her mission in life. Every time you take a spoonful of sugar, it's worth remembering Dr. Janki Amal, because her research is what added that extra bit of sweetness.
RCB has a pool of talented and hardworking women. RCB acknowledges the value and their contribution to the community. Now we would like to introduce RCB's Women Power.
Regional Center for Biotechnology is located in a tranquil environment along the Gurugram-Faridabad Expressway. It is an autonomous institute established under auspices of UNESCO by the Department of Biotechnology, Government of India. The primary focus of RCB is to provide world-class education, training to create high-quality human resource in biotechnology and conduct innovative research at the interface of multiple disciplines. The infrastructure at RCB has developed at a rapid pace since inception of the institution in 2010, with state-of-the-art research labs, teaching labs, innovative classrooms, central instrumentation facilities, small animal facility, biosafety level 3 facility, a biorepository and state-of-the-art advanced instrumentation facilities like the Advanced Technology Platform Center and a bio-incubator which serves as a reservoir for incubating ideas in the area and help them reach commercialization. There are various areas of research in RCB. The research group under the area titled Cell Biology, Development and Behavior focus on unlocking the secrets of cells, how they divide and how stem cells develop into muscle, in addition to studying the cellular and molecular origins of how organisms behave. Areas of agricultural biotechnology aim to tackle some issues by harnessing the existing genetic diversity in plants and their inherent capacities to adapt to abiotic and biotic stress conditions in order to develop innovative and durable methods of crop improvement. Groups working on infectious diseases, both bacterial and viral, aim at developing novel therapeutic strategies against infectious agents using tools such as mass spectrometry and microscopy. These researchers will shed light on cellular and molecular basis of bacterial infection and the response of the human host towards these infections. They are trying to find novel solutions to protect the people against diseases such as chikungunya virus, Japanese encephalitis virus, and dengue virus. Protein structure and design groups are structural biologists who have a molecular view of life and use cutting-edge methods like macromolecular X-ray crystallography or cryo-electron microscopy to imagine biological molecules in their functional state. This information is used to develop novel therapeutic strategies against pathogenic bacteria and viruses, and for protein engineering to prepare molecules with desired properties. Researchers at RCB are also working towards developing innovative biotechnological applications such as novel drug delivery systems, new diagnostic tools, novel engineered protein with improved desired proteins, and improved methods to obtain desired products in large scale. These researchers subject laboratory and clinical samples to cutting-edge microscopy, proteomics and genomics methods coupled with flow cytometry to shed light on the etiology of disease and utilize this knowledge to identify solutions to these disorders. The quality of research conducted at RCB is excellent, with faculty winning top honors like the Shanti Swarup Bhatnagar, the National Bioscience, the Innovative Young Biotechnologist Awards, and the Ramanujan Ramalinga Swamy and DBT Wellcome Alliance Fellowships. Since research-based learning is the hallmark of RCB, the academic programs here are deeply enmeshed with the research programs. The academic programs fulfill RCB's core mandate to provide quality education and training in the area of life sciences and biotechnology. The PhD program in biotechnology is for students who are interested in working at the interface of multiple disciplines to find novel solutions for problems in health and agriculture. RCB has recently started integrated PhD program in biotechnology. offered to students with graduate degree in any discipline of science from India and abroad. The program provides extensive learning opportunities in the broad field of life sciences and biotechnology. RCB has also recently initiated an interdisciplinary doctoral programs in the area of biostatistics and bioinformatics through collaboration with the global pharmaceutical giant GlaxoSmithKline (GSK), being conducted in partnership with other institutions by creating a virtual faculty pool. The focus of this program is on creating specialized manpower for the healthcare industry. As an outreach activity, RCB also offers research training programs for research-driven undergraduate and postgraduate students of science from various universities. Trainees get a realistic experience of several facets of modern biological research that sets the tone of their embarking on a research career. Throughout the year, RCB hosts and organizes regular academic events like the RCB Bioimaging School, national and international conferences, seminars, symposia, and training in the frontier area of basic and applied sciences in topics such as infectious diseases, drug discovery, etc., to disseminate advanced knowledge, exchange ideas, foster national and international collaborations, student exchange, and networking opportunities. RCB also holds scientific communication and communication workshops for the benefit of young scientists in India. RCB has a fully functional library and houses 500 scientific textbooks and 100 administrative books in multiple copies. In addition, an electronic library provides access to a vast range of primary literature in the form of peer-reviewed journals and reviews. RCB offers faculty residences and excellent students' facilities, including on-campus air-conditioned hostel accommodation, modern library, meeting rooms, seminar rooms, and auditorium. The hostel and student facilities are conveniently located and only a short walk away from the classrooms and laboratories. In addition, the campus also has sports and recreation facilities which encourages all-round development of the students. Campus also provides a childcare facility for all students and staff to help them continue their studies and work while their babies are being taken care of. Kridangan, the creche housed in the faculty building, is an asset on campus for employees of NCR Biotech Cluster. The spacious cafeteria in the campus serves hygienic, nutritious, and delicious meals and beverages at reasonable cost. RCB also contributes towards creating resource for researchers from all over India and has engaged with institutions such as the European Synchrotron Radiation Facility in France towards this end. RCB is also involved with the UNESCO towards developing policy to ensure sustainable development at the global level and specifically in the Asian region. RCB is a young institute which is growing day by day with excellent opportunities for young people to make a career in the area of biotechnology.